Hello everyone, welcome to video 5 of chapter 3. We continue our discussion on the solution for linear programming problem. Let's begin with some further comments based on our previous video. We see that, first comment, once we manage to write the constraint equations in a canonical form, then the basic variables can be all expressed in terms of the non-basic variables. Okay, we have seen an example on that. Then a consequence of this comment or this remark is the following. So if this is a linear programming problem, which comes with an objective function, which is written as a function f of all the variables. Some of them are basic, some of them are non-basic. And if we have done the first step, then we could actually remove all the basic variables in these objective functions because they can all be expressed in terms of the non-basic variables. Okay, let's take a look at an example. Okay, so this is a linear programming example. We want to minimize a function f depend on 4 variables taking this form x1 minus x2 plus 2x3 minus 5x4 and subject to the constraints listed here. So these two equations might look familiar because that's exactly the equation we have taken example with. And then we have the additional constraint that the variables are restricted. And we know that in our example, we did the pivoting x1 in equation 1 and x2 in equation 2. And after pivoting, these two basic variables can be expressed in terms of the non-basic one. So these two are taken from the previous example. These two equations are actually stated there. Okay, so x1 can be written as a function of x3, x4, and x2 a function of x3 and x4. Then it is rather obvious that we can now plug in the expression for x1 and x2, and then the function f now depends only on x3 and x4 by a simple manipulation. So x1 here is replaced by this expression, and the x2 here, it actually equals to that, and so we put that in the space of x2, and then we copy the x3 here and the x4 here. And now you see we only have x3 and x4. Okay, you can work a bit and collect like terms. The 3x3 terms can be joined into one, and the x4 terms can also be joined into one. You can add up the numbers, and then we also have a constant term, 5 minus 1, which is 4. So the objective function is written in terms of the non-basic variables only. You can do that. Okay, now we can summarize. The linear programming problem now can be written as follows. Minimize some quantity z, which is expressed as a function of non-basic variables plus a number, and subject to the constraints, which here it's written all in canonical form. x1 and x2 are the two basic variables. Okay, so for this problem, we can write out the basic solution, which we know is feasible. So the basic solution will be basic variables equal to the right-hand side of the equation, so x1, x2 taken here, and the non-basic ones are 0. Okay, so you should know where I get all these numbers from. This 5 is from here, and this one is from here. And at this basic solution, what is the value of z that we try to minimize? The objective function. Well, we see that it's written in terms of only the non-basic variables, which are 0 at this basic solution. So you only get the constant term here, 4. So pay attention. I got this 4 from this number. It's actually there. There's no computation needed. I just need to know where to get it. Okay, so another terminology. This linear programming problem that's in this shaded block area, if you have written one in this form, that is, the constraints are in canonical form and the objective function is written as a function of the non-basic variables. If you have it like that, and then this is positive, that is all feasible, then we call the linear programming problem is in a canonical form with basic variables x1, x2, that you need to specify the basic variables. Okay, so another term. So I would like to comment on or catch your attention to not to get confused with the canonical form, because we have multiple definitions. We have defined the constraint equations to be in canonical form, that is this. And here the definition is the canonical form for the linear programming problem. So we have a additional piece of information on the objective function. Okay, so they are connected and slightly different definitions there. Okay, so let's be formal and spell out exactly what we meant for a LP problem to be in canonical form. Okay, so here's a formal definition. The standard LP problem is in canonical form with a set of basic variables, which you need to specify. And we have the following conditions to be met. So 1, the system of constraints is in canonical form with the same basic variables. Okay, so this definition we have given in previous videos. And then, second part, the associated basic solution is feasible. And then the third part is with the objective function. One should express the objective function in terms of only the non-basic variables, as what we did in the previous example. Okay, so think about this definition and try to understand it and remember it, so it's at your fingertip, because later on we will be using these terminologies and details of the definition over and over. So it's good to wipe out any confusion and to get all concepts crystal clear in your mind before we proceed. Okay, that's all. Hope you enjoyed it, and I will see you next time.